In this video, we will learn about control flow in Python. Control flow refers to changing the course of the program when something happens. So we will learn about three ways of controlling the flow in the program. You will learn about conditional statements, if, else, loops, including for loops and while loops, as well as error control using try except statement. Now, conditional statements and loops both rely on providing a certain condition under which a certain block of code will be executed. Try except statement, on the other hand, rely on anticipating some error to happen and then dealing with it when it happens. So let's start by looking at conditional statements, if, else. So the idea is that we want to execute a certain piece of code depending on a certain condition. This condition is plugged in the if statement, which has the syntax if and then condition and then the colon. And underneath the colon, everything here is a block of code. It can be any number of lines, not only one, that belongs to the if statement. So what basically we're trying to say here is that if x is equals to 0, print x is 0. That's the if statement. Now the if statement can be a standalone statement. So we can express that what happens if the condition is true. So for instance, in this example, x is minus 15. So if x equals to 0, prints x is 0, of course it will not print because it's not 0. Now most likely this value will not be hard-coded into the code itself. Most likely this value will come from elsewhere, from other data sources, from input from the user. So to make this example more interesting, I'm just going to use the input function to read the input. So now we enter a certain input, and if the input is 0, it's going to say x is 0. Okay. Now you may kind of wonder why it's not saying x is 0 in this case. Well, in this case, because the function input is returning a string, the string 0 that we entered is not actually the number 0. So what's going on here under the hood is that we have to provide a string comparison rather than comparing x to a number, because the function input returns a string. So we'll do that again, and if we enter x as a 0, it's going to say x is 0. The other way to handle this scenario is to convert x to an integer. And this assumes that the user is inputting a number here. So if I put 0 now, it's going to print x is 0. If I provide any other number, it's not going to print anything. Now, optionally, to the if statement, we can provide else if and else statements. The else statement is simply what happens if the condition is not satisfied, if the condition is false. So that's the opposite kind of course of action. So we can do something like print x is not 0. So in this case, if I enter any number which is not 0, I'm going to see x is not 0. So the if block will execute if the condition is true, the else block will execute if the condition is false. Now, in addition to the if block and the else block, you may have an optional or many optional else if blocks. So let's go to the original formulation of this example here. That's basically saying that if the input, so I'm going now to, because this is referring to x in many places, I'm going just to change x to an integer. So I'm going to do x is equal to int of x, basically converting it. So if x is 0, print x is 0. Otherwise, if else is greater than 0, print x is positive. Otherwise, print x is negative. Otherwise, print x is unlike anything I've ever seen. which probably will not be executed because we know if x is a number, it's either 0, greater than 0, or less than 0. Okay. So in this case, if I put 4, it's going to be positive. If I put minus 4, it's going to be negative. Okay. So this is just the structure of the if-else statement. We will see more meaningful usage of this, of the conditional statements in the exercises. Now let's take a look at the loops. In contrast to an if statement, a loop keeps repeating a certain block of code while certain condition is satisfied. We have two types of loops in Python. There is a for loop and there is a while loop. The for loop basically iterates over a sequence. So you have a certain sequence and you want to go over the different items in this sequence. If we take a look at this example here, we can see that we have a sequence which is a list 2, 3, 5, 7, and we have a for loop that says that has this syntax for n in 2, 3, 5, 7. That's basically iterating over the sequence. And here is what we need to do in each iteration, which is basically printing n and using the separator to be white space. If we don't provide this one, each number will be printed on one line. Okay. So in this case, it's simply printing the items in the list side by side with a space in between. So we notice here that the components of the for loop are for in, right, and for the variable name that we will refer to within the loop in the sequence value or the sequence variable that we have. So in this case, it's a list. Let's take a look at this example here. I'm going to do for C in hello, print C and is equal to space. Now you can pause for a minute to kind of think about what's going to happen here. Here are some scenarios. Do we get an error here? If we don't get an error, what do we get as a result? And why would this happen? Why would this work? Alright, so let me run the code here. We got hello printed out with a space in between each letter. Now this code works because a string is a sequence, right? A list is a sequence, and a string is also a sequence of characters. So basically this loop is saying go for each character, which will be H, E, L, L, and O in this sequence and print the character, and then a separator of a white space. So we end up having each character printed and then a white space and the next character and so on. So we can iterate over a string very much like iterating over a list. This is a very common kind of a template for a loop that we may see very, very often. Basically, we want to iterate over certain numbers. So let's say I want to go over numbers from 0 to 9. Well, of course, I can do something like this. I can do for each number in between 0 and 9, 1, 2, 3, 4, 5, 6, 7, 8, 9, right? And print the number and a separator of a white space. Yes, and I made a mistake as well. 1, 2, 3, 4, 5, 6, 8, 9. Of course, this gets tedious, and let's say I want to go from numbers from 0 to 99. There is a function called range, which basically, as the name implies, give us the list of numbers in between 0 and the parameter of this function -1. Now this is slightly inaccurate because range doesn't give us a list, doesn't give us a sequence. It gives us basically a generator expression. You can think about this as giving you the items one by one without creating the whole sequence at once. Now, let's take a look at range 10. Let's copy range 10 and paste it in its own cell. you can see that we don't get anything. It's kind of repeating itself. But if we pass in range 10 to a list, you can see that range list can convert to the list of numbers between 0 and 10 minus 1, 0 to 9. So what's happening here under the hood, when we plug in range 10 in a loop, it's going to give the loop these numbers in a sequence. Now range as a function, this is one of the global functions that we saw a couple of these in Python, is very useful because we can give it other parameters. Of course, again, as a reminder, if you want the help or if you want to read more, you can do help, or you can do range and then question mark. And this will basically give you the documentation of that function. So by default, range starts from 0, but we can provide a starting point. So if we do range 5 to 10, we get 5 to 9. So we get from the starting point inclusive to the endpoint exclusive. We can provide an additional step. By default, it goes one by one, but we can provide an additional step. In this example, the step is 2, so it goes from 0 to 10 minus 1 with a step of 2. So it goes 0, 2, 4, 6, 8. And of course, 8 plus 2 is 10. It stops at 9, so that's why we don't see 10. It stops at 8 in this case. This is very useful, and we will see that it's useful to iterate over sequences as well, which is something we will get back to next week when we learn more about lists and other sequences and collections in Python. So the for loop relies on the availability of a sequence that we want to iterate over. The while loop, on the other hand, relies on a condition, very much like the if statement. Now, in contrast to the if statement, the while statement will keep repeating the block while the condition is satisfied, while the condition is true. So let's take a look at this example. Now, before running the code, I'm going to do a small change. I'm going to do if instead of a while. Just to show you that this code can work if I put in if and we get 0. So let's kind of trace this through this code step by step. In the beginning, I was equal to 0. And then if I is less than 10, which is true, I'm going to print I with a white space. So it prints 0 and a white space. You can see the white space here. And then it increases I by 1. So if I probe into I can see that the value has been increased to 1. Now this is an if statement, which means this thing will run only once. And then after it runs, once it's done. Let's take a look at what happens when we plug in a while instead of an if statement. This piece of code will keep running while the condition is true, right? And what's going here is that in this block of code, I'm printing I and then I'm increasing its value by 1. Which means I'm going to get numbers from 0 to 9 because I'm going to stop at 10 because 10 is not less than 10, right? And if I probe into the value of I here, maybe you can pause for a second before continuing. What would I see, 10 or 9? Well, the value is 10 because I increased to 10 at the last iteration. It printed 9, it increased to 10, and then went back to the condition, which was false, because if you do I less than 10, it's false, which broke the loop. This is a very important point. Whenever we have loop, we need to ensure that the loop breaks at some point. Otherwise, we have what we call an infinite loop, which is basically considered a problem, a bug in the code, because it will freeze the notebook or your code forever because it's an infinite loop. There are two kind of scenarios when an infinite loop may arise. One of them is that your condition is not properly written. Let's say you do something like while I is less than less or equal to I'm thinking of an example. Let's say, for instance, I is greater than 10, and we start from 10, right? This will keep repeating forever because, or I is greater or equal to 10, because your condition here will remain true because you're increasing I one by one, which means it will keep doing this um, forever. Now, I'm going to try to run it. I'm hoping I don't freeze my kernel, so let's see. Okay. If this happens to you and you see this star forever, it means this is like still executing code. And in my case, I know it's an infinite loop, so I have to stop it. You have to do kernel interrupt to interrupt the kernel, because you're printing numbers forever in this case. That's scenario number 1 for an infinite loop. Scenario number 2 is to forget that condition, which is called the increment condition here. If you forget to increase I by 1, you will keep printing zeros forever. So while I is less than 10, 0 is less than 10, print I, and it goes back again, and 0 is less than 10, and so on and so forth. So again, that's an infinite loop, and we don't want to print zeros forever, so let's interrupt. Two statements may be useful to fine-tune the loop: break and continue. Now, break, as the name implies, breaks out the loop completely. Continue skips the remainder of the iteration to the next one. Let's take an example here. So for n in range 20, so range 20 will be numbers from 0 to 19. If n modulus 2 is 0, which means if n is an even number, continue, right? And notice there is no else statement here. The next statement in the loop is to print end with a white space separator. So the end result of this is printing odd numbers, because if the number is even, I'm skipping to the next iteration, to the next n in the loop. So let's take a look at what's going here under the hood. What I'm going to do here, I'm going to print let's do n is equal to n, and instead of a white space separator, I'm going to go the default. So that basically will print n on a new line. Now look what's going on in here. Well, first we start with n is equal to 0, right? Next we go in this if statement, because 0 modulus 2 is equal to 0, I continue. And the next n is 1. Now 1 modulus 2 is 1, is not 0, so I don't continue, I print n, hence 1 here. Okay? So continue skips to the next iteration in the loop. Let's see what happens if I do break rather than continue. Now, if I break, not only the current iteration breaks, but the whole loop also breaks. N is equals to 0. If n modulus 2 is 0, break, which means I completely break out of the loop. I don't even print n, I don't even go to the next iteration. One common use case of the break statement is to have a loop with a true condition and a break within the loop under a certain condition. So in this example here, this loop is doing some mathematical calculations and it's breaking at some point, and this point is at a certain maximum number. You can see that the while is an infinite loop because it's while true, but there's an if statement coupled with a break statement. This usually happens when I don't know beforehand the condition, the condition or the value of the condition that I want to use in the loop. Let's look at this example here. Let's say, for instance, I'm setting up a guessing game. So number is equal to, for instance, 5, 5. Let's say this is kind of a game of guessing. And let's say I would like the user to guess a number in number 55 in this case. We will make it different shortly. So what I can do here, I can do while true, and then I'm going to do print guess my number, and I'm going to tell the user that it's in between 1 to 100. Guess my number between maybe 0 and 99 because we're programmers, or maybe 1 and 100. It doesn't really make a difference here. And then I'm going, user number will be int of the input. Okay, so here's what I'm going to do. If user number equals to the number, I'm going to print bravo and then break, so the game is end now. Else, I can keep it as is. I mean, I don't need an else statement here. It will keep repeating forever here. So if I do 33, 44, if I do 55, it will break, right? Let's make the game more interesting. I'm going to give the user hint. Else if user number is less than number, I'm going to print too low. And in the last situation, I'm going to print too high. So it's kind of like a traditional kind of number guessing game. So if I do, for instance, 33, now it says too low. If I do 66, it will say too high. But if I do 55, it will end the game. The point in here is that the break statement breaks the loop. If I don't have a break statement, it will simply say bravo and continue the guessing game. And because this is an infinite loop, now I need to interrupt the kernel. Okay. Now you may wonder that this is like a silly game because this number is always set. I mean, this is outside of the scope of this, treatment of loops and conditionals. But there is a package called random, which generates random numbers, and we can use this package to generate random numbers. So like what I'm going to do, I'm do random and random int, or let's see, random int. Now I'm not sure about random int, whether it provides in between 0 and this number -1. So what I'm going to do, I'm just going to take a peek at the function documentation here. It says random in range A to B, including both endpoints. So since this is in between 1 and 100, I can do 1 to 100. Now it's a challenging game. So what's the number? I'm going to do 50. It's too low. So maybe 75. That's too low. Okay, so maybe 88. Well, that's too high. So now I know my number is in between 75 and 88. No, 70, how about 80 or 81? 81 is too low, so now it's in between 81 and 88. How about 85? 85 is too low, so now I know it's 86 or 87. What, 86? Okay, 87. Bravo. That took a bit more time than I anticipated. Okay, so I can see that combining loops, conditionals, controlling the loop, we can write programs that exhibit some interesting behavior, such as this number guessing game. All right, unfortunately, errors happen, right? And you've probably seen something like this, like you type in something and then you get like an error message, and then you need to figure out what happened here. So here I'm trying to print magic, and basically the name magic does not exist, is not defined. So I'm printing something that is not defined. What's the value of magic? It doesn't exist, and I get this name error here. Let's take a look at this error. If I do 1 divided over 0, it's basically a division by 0 error. Now, this kind of error is different from this one. This one is kind of what we call a syntax error. The syntax is incorrect. The variable doesn't exist. This one is kind of more of a runtime error. The syntax is fine. You can divide two numbers, except that division by 0 is not defined. This one we have seen. 1 plus 1, you cannot convert unsupported types. Type error. Float 1, it's a value error. You only can convert numbers written as numbers in strings. So there are different kinds of errors here, and any program is prone to errors. Like even the code I wrote here, what happens if the user doesn't enter a number? You get value error because you're trying to convert that number to the entry to a number, right? And if the entry is not a number, the code will not run. Now, if there is an error, Python will stop and you will get the error message statement. So if you were running this code in a batch mode, like if you were running all of the cells, the execution will stop at the error point, which is usually a problem if you're running this in a batch mode. You have a lot of data to process, you get an error and nothing will happen afterward. So that's why Python and all other programming languages provide ways for us to deal with errors. Now, errors are kind of a bit unanticipated, unlike conditions and loops when we know what we're doing. So that's why kind of the dealing with error statement is called sometimes catching the error. You're trying something, and if something happens, you need to catch, or if you expect something to happen, you need to make an exception for that. The statement in Python to deal with errors is called try except. This statement has a bit, some bells and whistles, so we're not going to go through all the details, but I will cover the basics here. Let's take a look at this example here. In this example, I'm reading two numbers, and I'm trying to divide one number over the other. So far so good. If I enter something that is valid, I can divide the two numbers and I get the results. But there are so many things that may happen. One of them is obviously if there is a typo. And in this typo, just an extra keystroke, 4R is not a number, you cannot convert it, so you get a value error. That's one thing. The other one is that if for some reason the user does flow a division by 0, which is not defined, we get an error, right? And there could be other issues like, I try to kind of anticipate many things to happen, but there could be things that I don't know, I cannot anticipate. So let's take a look at the basic way of capturing this error. The statement or statements that I anticipate to generate an error, which is those two statements in my code, because I also have the input as well, and I can definitely put them under try, but let's say I'm focusing on those two statements. I put them in the try statement, under a try statement. So try colon, and this block of code belongs to the try, meaning Python will try the code, and if something happens, it's going to transfer the flow to the other part of the statement, the except part. So except meaning there is an exception, there is something exceptional to deal with, an error. And in this case, I'm just printing something went wrong. So now if I do this, same example again, I don't get an error, I get something wrong happened. So this is kind of a gracefully dealing with the error rather than just printing the default error message here. Now in this example here, and of course if I do the second example, 4 over 0, I'm going to get the same, something wrong happened. In general, it's possible to to have an except statement for different kinds of errors. And the different kinds of error you know about, because those are the errors. The type of the error will be indicated to you when you try to run the code in Python. So like division, the zero division error is called zero division error. If you have a type conversion error, you will get a value error. So this piece of code here has two except statements. So basically I'm anticipating two errors, zero division and a value error. And in each one of these, I provide a different course of action. In this example, the course of action is just one print statement, so it's not a big deal. But in general, you can customize it depending on the scenario, the situation. Let's say you're reading from a database and the connection is unsuccessful. Maybe you need to provide a certain course of action, such as double checking the credentials, for instance. So there are different course of actions depending on the different errors here that you expect to deal with. So in this case, if the error is division by 0, we will print cannot divide by 0. If it's a type conversion error, we can type in only numerical values are allowed. And I can provide a general except statement for everything else. But this is kind of like, it will catch all. If the error is neither zero division or value error, we go to this general except statement and print something wrong happened. Which is usually a good practice, because in this case, I can't think of something else than value or zero division. But again, I cannot anticipate all possible scenarios. So maybe there could be a third kind of error that I haven't thought about. Okay. Let's take a look at this example here. And this is kind of combining loops and error statements to make the code as bulletproof as possible. I want to keep trying doing things until I'm sure that the values can be divided. So what I'm doing here, I have a loop while true, so it will keep repeating this whole thing forever. Well, not forever, because I have a break statement. So read two numbers, and then try, convert the first number to a float, the second number to a float, and divide, and then print the result. Then break, which means break the loop and finish. If there is any error, division by 0 or value error, print an error statement here. So now, if there is a certain entry incorrect, it's going to print an error statement and keeps going into this loop until the values can be divided, print the results and finish. Right? So this is very useful because this piece of code is much more robust than the previous one. This is something we deal with a lot when we have data coming from the outside, data conversion. We need to deal with different kinds of errors. Let's go back to our code here, the number guessing game. Okay, so the potential of having an error, one of the potentials of getting an error is basically here, user number. So I can make this more kind of bulletproof by trying to plug in a try except statement here. Okay, you can pause for a while and try to do it on your own. Here's what I'm going to do. I'm going to do user number is input, and then try user number is equal to int user number. And so trying to convert, if something happens now, please enter a valid number. Okay, but now I need to do something, because if this is the case, please enter a valid number, it's going still to compare the number with the number, and it's still going to do this comparison here. Right? And then we get a problem here because we cannot compare a string with an integer. So what do we do here? Very similar to what we've done in this exercise, except that rather than breaking, I'm going to continue. The reason is here is that if I break, it's going to break the whole loop. Now, the number guessing game requires the user to go over many entries in comparison to the division game, which is basically one valid entry and you're done. So instead of breaking, I'm doing continue, which basically will transfer me back to the beginning and go with the next iteration. Okay, so now the game is going on. Too low, too low, I'm getting high numbers, too high, so it's in between 77 and 88. All right, so I'll keep enjoying this game after this video. I'm going to move forward and talk about the warm-up and the warm-up workout exercises in the two next videos. Hope you enjoyed it.